Hello, Geometry, Chapter 6, Lesson 5. We have something called an indirect proof. Yes, proofs are coming back again. And inequalities in one triangle. 6.6, the last one will be inequalities in two triangles. But pretty exciting stuff there. But inequalities, remember this phrase here refers to things like a less than sign and a greater than sign. We won't really have the less than or equal to or greater than equal to. Okay, an indirect proof obviously would be the opposite of a direct proof. Direct proof is where you have something you want to prove, and you try to prove that based off the information that you know. An indirect proof is going to basically try to work a proof through the back door and try to say you're going to make an assumption that something is wrong, and then you're going to find that that can't happen, and so then you're going to prove it by proving a contradiction. Or having a contradiction within your proof. So we'll look at that a little bit. You won't have to do a whole lot with actually writing them, but I do want the understanding and mindset how you can assume something is true and then prove that it can't be that way, so it has to be false. So if I want to prove that I am Mr. Brian Dean Leitner, that's my full name, I can make the assumption that I'm not, and then through my research I'd find my birth certificate and say, oh, here it says my name is, so my assumption must be wrong, therefore my original statement must be true. Okay, so we'll talk about that here. I think that's kind of the first thing though. But here are the essential questions. How are the sides related to the angles of a triangle, and how are any two sides of a triangle related to the third side? And we'll look at some diagrams, and I got the handy dandy little triangle pieces coming back here again as well. I think it starts with an indirect proof. We'll get through that first. We're not going to do any, that's from the previous lesson, any of the explorations here. That would explain it, but I think most of this you'll get pretty well. Okay, so what an indirect proof is, it uses what they refer to as indirect reasoning. So used is indirect reasoning by making a temporary assumption that the desired conclusion is false, you will come to a contradiction of your hypothesis that leads to a logical impossibility. Ooh, that's a big one there. Big definition. It uses indirect reasoning by making a temporary assumption that the desired conclusion is false. You will come to a contradiction of your hypothesis that leads to logical impossibility. This end state proves that your assumption is wrong and the original statement has to be true. Okay? So here's kind of what they have from the textbook. Okay, I can read it off to you, but I think it's a little bit easier if you can see it as well. So a student looks around the cafeteria, concludes that hamburgers are not being served, and explains as following. Okay, so at first I assumed that we are having hamburgers because today is Tuesday, and Tuesday is usually hamburger day. Okay, so if it's Tuesday, then it's going to be hamburgers for lunch. There is always ketchup on the table when we have hamburgers. So I looked for the ketchup, but I didn't see any. So my assumption that we are having hamburgers must be false. Okay, so the assumption was we are having hamburgers today because he thought it's going to be Tuesday. That assumption must be false because he doesn't see ketchup on the tables. So his assumption is false, so that means the opposite has to be true, and they're not having hamburgers. Okay, so it must not be Tuesday. But then they have that word there usually, so it doesn't have to be that. It's not guaranteed. So what your questions will be like with your steps, identify the statement you want to prove. That's going to be a big part of what your questions will be, okay? Assume temporarily. That phrase right there is a phrase that we're going to start everything with, that this statement is false by assuming that its opposite is true, okay? So here, the questions will say something like, what is the first step in an indirect proof? Okay, you can pause it and write this down and write this example down if you want. And so the proof is if A equals 2 and B equals 3, then A plus B equals 5. This is our conclusion. Okay? So the first step is assume temporarily that this statement, the conclusion, is false by assuming that its opposite is true. So that first step would be, we would assume I forgot how to spell temporarily real quick. Assume temporarily that A plus B does not equal 5. A plus B does not equal 5. Okay, and you can kind of look at this and know that this is not going to work out here, because we can assume that it doesn't equal 5, but then you're like, well, but A equals 2 and B equals 3, and 2 plus 3 does equal 5. Okay, if you're working in base 10. So 2 plus 3 does equal 5, so therefore our assumption is false, making this true. Okay, it kind of goes back to a little bit of a logic. If something's false, the opposite or the negation of that has to be true. Okay, so you're assuming that not Q is true. Reason logically would just be, hey, we know 2 plus 3 is 5. And then you point out that the desired conclusion must be true because the contradiction proves the temporary assumption is false. All right, so let's look at your questions you'll have with that. They're on page 188. It says, write the first step in an indirect proof of this statement. Okay, so we have not all the students in a given class can be above average. Okay, not all the students in a given class can be above average. Average is referred to as kind of the 50th percentile. It splits the class in half. Okay, so if you have everyone above average, that just raises your average, and you still have half the class below average. That's your contradiction there. So we are going to start with the words assume temporarily that we want the opposite of this conclusion. So we're going to assume, it says not all, so the negation of a not would be taking that not off. So assume temporarily that all students in a given class can be above average, or shorten that up, can be above average. So you assume temporarily that all students in a given class can be above average. We would argue and say, well, average is the middle of the class, and if everyone is above where the middle is, then that raises the middle and you have a new middle, and then you still have half of them above, half of them below. Okay, number 2, no number equals another number divided by 0. No number equals another number divided by 0. So we are going to start with those magic words. Assume temporarily that the negation of a no would take the no off, that a number will equal another number divided by 0. Okay? So we assume temporarily that if you take a number divided by 0, you will get an answer. As we work through that process, we'll be like, oh, if you divide by 0, you can't have 0 groups of something that you have. Okay, I have all these pens and pencils here. I can't, if I want to divide these, how many groups of 0 do I have? Well, that just doesn't make sense. I can't have 0 groups of 0 because I have 4. 4 divided by 0 doesn't make sense. Okay, so then our assumption has to be false, making our original statement true. And finally, the square root of 2 is not equal to the quotient of 2 integers. Square root of 2, there's that word not. So we're going to assume temporarily that the square root of 2 does equal the quotient of any two integers. It does equal, okay, because it says it does not equal. The negation of that would be it does equal. Our argument there is square root of 2. That means you can divide two numbers and get the square root of 2, but we know the square root of 2 is a decimal that goes on forever. Therefore, it is not rational, making it irrational, and it is not the quotient. Rational, it means a fraction, a division problem, same as quotient, of any two integers. Okay, so square root of 2 is irrational. Okay, indirect proof, second set of questions that you'll have. It says, determine which statements contradict each other. Explain your reasoning. So they give you three options here, and you have to say, okay, which ones of these three would contradict each other? So question 4, we have triangle LMN is equilateral. Think about what you know for equilateral triangles. Item B says the length from L to M is not equal to the length from M to N. And then C is angle L is equal. That is a typo there. They didn't say the measure of angle L. It says angle L should be congruent to angle M. Okay, so we know equilateral, they have to have the same sides and all 60-degree angles. So they have to have the same sides. So equilateral is something that has 3 equal sides and 3 equal angles. So for B to be two sides not equal, that doesn't work. Okay? So B contradicts A. B contradicts A. And explain your reasoning. If triangle LMN is equilateral, then all the sides are the same length. All the sides are the same length. Okay, question 5. Look through there, see if you can figure out which two would contradict each other. We have a triangle. We have a right triangle. And it says angle A is acute, then it says angle C is obtuse. Okay, so if you have a right triangle, we know that one angle has to be 90. Remember, the two other angles have to be complementary. They have to add up to 90. So you cannot have another obtuse angle, because if you have a right triangle and obtuse angle, that's 90 plus something greater than 90, that'd be more than 180. So C contradicts A. C contradicts A. So you can't have an obtuse angle in a right triangle. Can't have an obtuse angle in a right triangle. Okay, so as we go back here, back to page 186, that was kind of the longer one. What we have here is a triangle longer side theorem. So these are the inequalities within there. It says if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So there's looking here. We have to know how to find the opposites of sides. So if here is side AB, its side length 8. And if you look opposite, its opposite angle is C. So 5, AB, this 8 goes with angle C. The 5 opposite would be angle A. And what it's saying here is this, since 8 is bigger than 5, this angle has to be bigger than this angle. Okay? If you look at a Desmos example here, these two lengths, here's an 8, here's a 5.65. The side opposite the 8 is a 90-degree angle. The side opposite of 5.65 is 45. That's a smaller one. Okay, that's going to hold true until it gets less than it. Now look, 4.6 is less than 5.65. So 53 is now less than 80. Okay, so the angles opposite the sides are in the inverse relationship to the sides. Or a direct relationship, direct relationship. So, what we have here is they want to know which angle is the biggest. List from the given information. So we know angle to 10, we have AB is 10, AC is 9. So we don't know what BC is right now, but we know that since 10 is greater than 9, here's angle C. So since 10 is greater than 9, the measure of angle C is greater than the measure of angle B. Okay, since 10 is greater than 9, C has to be greater than B. Look at this one over here. Get that drawn. And you're looking at 9.1 and 9.2. So opposite sides, there's A and there's C. So I'm going to say since 9.2 is greater than 9.1, so I put 9.2 first, the measure of angle A is greater than the measure of angle C. A is greater than C. Okay, so that's the triangle longer side theorem. The next one is the converse of that, and that's the triangle larger angle theorem. Okay, if one angle of a triangle is larger than the other angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So since the statement and its converse are both true, we could do a biconditional statement, if and only if, with this. So which side is longer? List from smallest to longest. So if we have 100 and we have 20, that makes this third angle 60 degrees. So they want the smallest side, okay, not drawn to scale. This is my smallest angle here. So the smallest side has to be AB. So AB is going to be this first one. AB is less than, okay, here's 68. This is my next side. So 20, 68, 100. That's the order we're going in. So 20 goes to AB, 68 goes to AC, and then 100 goes to BC. So we'd say AB is the smallest, and this is the largest. AB is less than AC, which is less than BC. Okay, smallest to largest, look for the smallest angle. It's 59, go opposite, and we're going to start with AB again. Now my second largest is 60, so 59 to 60, that's going to be BC. So AB is less than BC, or BC is greater than AB. And then my biggest one is 61, that goes to AC. Okay? So when you're doing these, you're just basically looking for the angles. You're listing them from smallest to largest, and then listing the sides opposite them, smallest to largest. Okay, the final one is the triangle inequality theorem. I have several examples here. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So what happens here? So look at this triangle here. It's saying these two, my green and my purple sides, these two sides added together have to be longer than the third side. Because if it's not longer, okay, let me get a smaller one here. So here are my two other sides. If this sum, if I put these together, get that on there for you, and this length is not longer than this length, you can't make a triangle with these three sides. Okay? I can hook up this one side for you, but it never will reach. It's not going to be long enough to reach over here. So two sides of a triangle have to be greater than the third side. So that leads to these questions here. Can you construct a triangle with the given sides? So we have sides of length 3, 3, and 7. It can be meters, inches, miles, whatever you want. And what you're going to do with these, you're going to add the two smallest numbers. It must be greater than the third. To make a triangle. So you're going to find your two smallest numbers, and it has to be bigger than the third in order to make a triangle. Okay, that's what we're talking about here. AB plus BC has to be greater than the third side. Two sides have to be greater than the third side. So two sides must be longer than the third side. So 3 plus 3 is less than 7, so that's a no. 3 plus 3 is less than 7, that's a no. Take your two smaller ones here. 4 plus 8 is greater than 9. That's a yes. 4 plus 8 is greater than 9. 4 plus 8 is 12. Here, don't take the first two listed, take the first two, the two smallest ones. Sorry, don't take the first two listed, take the two smaller ones. 3 plus 2 equals 5, and that is less than 10, so that's a no as well. Okay, so from the triangle inequality theorem, we can answer these questions here. Given two sides, find the possible lengths for the third side. Given two sides of a triangle, find the possible lengths. So let's say we have sides of 5 and 8. So 5 and 8. So let's assume this right here is a 5-piece and an 8-piece. Okay? So this sum has to be greater than what it is. Okay? So if I have, let me put this green one back on here. Okay, if I stretch these out and still keep a triangle in here, that's almost 5 plus 8 would be 13. So it has to be less than 13 because the two sides have to be bigger than the third side. Now if I put it this way, notice there's a really tiny triangle there. That's almost the difference. So if I take 8 minus 5, the other side has to be bigger than 3. It can't be a 1. Because if I have a 1 and a 5, 1 plus 5 is only 6. That's not bigger than 8. So how we do these is it has to be third side must be longer than the difference and shorter than the sum. It has to be longer than the difference and shorter than the sum. Okay, so 5 and 8. Let's go back and make this triangle here. So that's pretty close to 5. So I have a 5 and then I have an 8 here. This third side here, let's label that. If I stretch this out to 5, let's scoot this over here. Okay, so if I make this a line, there's 5. 5 and 8, that equals a 13. So if I want a triangle, if I want to keep it at 5, yeah, let's do this. Okay, if I want to keep it at 5 or close to it, you see that third side is always going to be less than 13. So it's less than 13, less than 13, less than 13. When I go over here, trying to keep that at class 5, you notice that has to be greater than 3. If I go right here, it's 3. It's exactly the 3. You don't have a triangle though. Okay, so that third side has to be greater than the difference. There's the difference, greater than 3, and less than the sum, less than 13. Hang on. Okay, so that's what we'd say here. Greater than 3 and less than 13. Greater than 3 and less than 13. Let's look at these examples real quick. Sorry, I know it's getting long here. Okay, this will go fast. Oh, I didn't switch that over. There we go. Okay, this is the last thing I wrote there was it has to be greater than 3, less than 13. Greater than the difference, subtract them. Less than the sum, add them. Okay, list the angles of the given triangle from smallest to largest. So this is the smallest side. This is the medium side. This is the middle side. And this is the largest. Okay, so 6, that means angle C. The measure of angle C is the smallest. And that's going to be less than, here's our middle one, go up to A, the measure of angle A, which is less than the measure of angle B. Okay, so smallest to largest. So here's my smallest side, look up, we have angle D, we're just going to list them now. Here's my next one, 15, so which angle is opposite 15? Angle E, and then here's 18, opposite that would be angle F. Smallest side is 11, so that'd be angle H, opposite. 14 is next, so angle J, and then 16 is next, angle G. So this one has to be your smallest angle. Is it possible to construct a triangle with a given side length? If not, explain why not. Okay, this is when you take your two smaller ones and it has to be bigger than your third. So 3 plus 12 equals 15, which is less than 17. So no, there's your explanation. The two sides have to be greater than the third side. 5 and 16, take the two smaller ones. 5 plus 16 equals 21, which equals 21. So that's a no, it has to be greater. That's your explanation. The two sides have to be greater than. Two smaller sides are 5 and 7. 5 plus 7 equals 12, and that's greater than 8. Yes. Two smallest sides are 3 and 10. 3 plus 10 equals 13, and that is greater than 11. So that's yes. Oh, 5 and 13. Okay, we already had a 13 here. So a triangle has two sides with lengths 5 inches and 13 inches. Describe the possible lengths of the third side. Greater than the difference, less than the sum. So it has to be greater than 13 minus 5, so 8 inches. And it has to be less than 13 plus 5, which is 18 inches. Okay, so there's your main series of questions. I mean, there'll be a little bit more with these triangles and stuff, but remember always the sides are smallest to largest in relationship to the angles. So, a lot of good information here. I wanted to make sure I went into plenty of detail and definitely went longer than I had planned there. But thanks for sticking with me. Hopefully the assignment goes easy for you. We'll see you in class.